Hello, everyone. I'm Prakash. I'm the vice chair in a study group networks at TSDSI. Today, I'm facilitating and moderating this session organized by TSDSI in collaboration with Indo-ICT standardization body. And multiple people will involved, but I thank Sachin for the initiative. The topic we have today is open air interface, democratizing innovation in the 5G era. And we have been in India trying to get more people to participate in standards. The ecosystem, as it grew from 2G to 3G, 3G to 4G, the number of participants sort of declined rather than increased as the years progressed. And in the ecosystem, the players got larger and the other players got much smaller. And one of the key challenges that we are all looking at is how can we democratize it? How can we bring more participants into the ecosystem? Towards this, we have this puzzle, one of the pieces of the puzzle. This is not the whole solution, but one of the pieces of puzzle. Key solution we feel in TSDSI is open source across the spectrum and specifically in the RAN aspects. And that is a topic that we have here, which we call the open air interface. And as we move to 5G, where the systems are supposed to get larger and more people get involved, okay, it is important for the community to have control rather than just a few players. Okay, there is no objection to anybody making money, but people would like to have that. So today I'm introducing Dr. Florian Kaltenberger. Okay, he's an assistant professor at EURECOM, and he works in the communication system department. EURECOM is a university in France, and we have, while visiting Nice, and anybody who's gone to HC meetings will be getting very close to where EURECOM is. And he's received his diploma and his PhD both in technical mathematics from Vienna University from 2002 and 2007. Dr. Florian is the part of the management team for the real-time open source 5G platform at OpenAirInterface.org. And he also serves as the General Secretary of the OI Software Alliance. He's currently coordinating the development of OI Radio Access Network Project Group, which has delivered support for 5G NSA non-standalone access in 2020 and 5G standalone access in 2021. He also manages several research projects, industrial, academic, around this platform and teaches a course on radio engineering. His research interests include 5G and MIMO systems at large, software-defined radio, signal processing for wireless communication, as well as channel modeling and simulation. In 2013, he's received the Neil Shepard Best Propagation Award journal article, experimental characterization modeling of outdoor to indoor and indoor to indoor distribution channels, which was published in the IEEE Transactions on Vehicular Technology. In 2016, he has received also the Best Demo Award in the project ADEL at the European conferences. Okay. Like we said, from TSDSS side, I would like to thank you and welcome you for volunteering to give this talk, and we look forward to your presentation. And we will have about 45 to 50 minutes of talk, and maybe about we'll monitor the questions. We'll have the Q&A in the end. Over to you, Dr. Florian.
Okay, thanks a lot. Thank you, Prakash, for that introduction. So without further ado, let me go right into the topic. So the agenda today, what I prepared in my slides today is the following. So I don't know the audience here too well, so I thought I'll give a general introduction to OpenAirInterface, what it is, what different projects we have. And I'll also spend some time on explaining the licensing model that we use in OpenAirInterface, because it's quite unique. and it's what makes this open source project stand out compared to other open source projects. I'll also spend some time talking about the OAI Software Alliance, which is an organization, a foundation to be exact, that was founded by EURECOM to support the developments, and that is available and that supports also developers and startups, entrepreneurs, and even bigger industry in their usage of OpenAirInterface. Then I'll spend a few moments to talk about the different projects within OAI. So as Prakash said, personally, I'm coming actually from the lower layers of the protocol stack. So I'm mostly at home at the radio access network project, the 5G RAN. This is the one I'm also coordinating within the alliance. But I'll spend a few words also on the core project and a recent addition to the alliance, which is the Mosaic 5G project. And at the end, I'm going to put all of this in a bigger perspective. So how OpenAirInterface fits into the puzzle or the ecosystem of cloud native Open RAN deployments. Okay, and I think this is very important because that's one of the main applications of OAI. And I'll finish by some conclusions and of course questions and answers at the end. So if you have any questions, please post them to the chat right away. Don't wait till the end, and Prakash will moderate them at the end. All right. So on one slide, what is OpenAirInterface? So the keywords here are that it's an open source software-based implementation of 3GPP technologies. Okay, so we started OpenAirInterface a long time ago, even before I joined EURECOM about 14 years ago. It was there, but it really became successful, and we got a lot of attention when we started to implement LTE Release 8, and we managed to show interoperability of our software with commercial components. Since then, 3GPP has released a lot of updates, so we always try to follow the different 3GPP releases. We included features from LTE Advanced, LTE Advanced Pro, and right now we're busy with implementing release 15, going on to 16, and we are on the roadmap. We also have we're also planning to implement features from release 17. OpenAirInterface is the most complete open source software in the sense that it spans the full protocol stack. So it includes both the radio part, so the EUTRAN, which comprises the E node B, G node B, but also UE and for the LTE UE and the NR UE. We have a 4G core network, also called the EPC, Evolved Packet Core, which is comprising of MME, SMP Gateway, HSS. And since recently, we also have a 5G core network, for the moment comprised of the AMF, UMF, and SMF, but more in development, and I'll talk about this later. OpenAirInterface runs on general purpose CPUs, so it runs on the Intel x86 architecture, and some parts also on ARM. And it can run in real time, so you can operate a real-time network with it, but it can also run in simulation or emulation platforms. So you can also use this as a tool for simulations, link level simulations, system level simulations, and so on. When we run this in real time, we usually rely on off-the-shelf software-defined radio platforms. So historically, we use a lot USRPs, but it also works with more commercial and equipment like remote radio heights from Benetel or AWS. So OpenInterface makes it feasible to put a fully compliant 4G net eNodeB and 5G eNodeB in a commodity x86-based computer or a data center, yeah, in a cloud run or a virtualized run deployment. So OpenInterface was started by EURECOM 15 years ago, and now it has grown beyond EURECOM. But the reasons that we're doing this are still the same. So we want to build a community of developers, academics, and industrial players embracing open source for 5G. So OpenInterface gives them a platform to work together. So for industry, it's a platform that is relevant, that is very close to real deployments. For academics, it's a great opportunity to jump into something that is don't have to start from scratch. So it brings this two together. We provide the reference implementation for 4G, 5G, HPP systems, and one of the goals is to allow the adoption of the software in other projects or products. So today, let me talk about this here first. So in 2014, after the initial success of OpenInterface, we created this OpenInterface Software Alliance. Since EURECOM is a French entity, we created this in France. So it's a fonds de dotation or an endowment fund in English, which allows to receive donations. So it's very similar to the Linux Foundation, for example. And with these donations, we support, we finance the support activity of the OpenInterface software. So the OpenInterface Alliance is responsible for the continuous integration, continuous deployment. We have now also other engineers that even help with the development. And another goal of this alliance is also to promote OpenInterface in general and its open source licensing model. We have 8 strategic members today. You see them here. So we're from France. We have Orange, and very recently Sequence joined. Sequence is a chip maker in France for mostly IoT devices. Then in Japan we have Fujitsu, and the rest of the members are from the United States. Xilinx, InterDigital, Facebook, Qualcomm, and PAWR, Platforms for Advanced Wireless Research, which is a big community in the United States. So now let me show this here. So these are the projects that we have today within the OpenInterface Alliance. So there's the 5G RAN project, the 5G core network, and the Mosaic 5G project. So these projects, so these are the so-called project groups. They have been created rather recently in the Alliance, and they so we basically now can accept donations dedicated to one of these particular project groups, and the OpenInterface Alliance engages in delivering certain features within those project groups. Okay. And I'll tell you a bit more about these different projects in a few minutes. But before that, let me spend a few words on the OAI licensing model. So almost all of the components of OpenInterface are licensed under the so-called OAI public license 1.1, which is based on the classical Apache v2 license, but with the difference that it allows committing software with patent rights. So in classical open source software, or for example in the Apache v2 license, if you have a patent on some technology and you implement the technology in open source, you basically will lose the rights to your patent. Anyone can use this open source implementation, and they don't have to pay royalties to you anymore. And we realized actually through our partners that this licensing model is not compatible at all with how 3GPP works. 3GPP, the reason, one of the reasons why 3GPP is so successful is because its member companies are the business model of the member companies is based on patents. So any company who innovates within GPP first patents the technology before bringing it into 3GPP, and that allows them to collect royalties and then finance their innovations. So it was we realized that if we want to get close, bring open source to 3GPP, we have to respect that. Okay, so we added this clause into this Apache license that allows anyone with patent rights to keep their patent rights while still contributing to the open source. Okay. So it's free. It says in this license, if you use it for research and development, that's fine. There's no change. Basically, the basic Apache v2 license clauses apply. But if you want to go out and commercialize the software, it clearly states that you have to respect the fair, reasonable, and non-discriminatory clauses of 3GPP. So you have to go to 3GPP and pay your royalties there if you use this in a deployment. So this licensing model has received good feedback, even from outside the OAI community. Etsy and also others have given us good feedback on this licensing model, and it's even being adopted in other projects. There are just a few elements of our code. So in particular, the MME and the HSS of the 4G core network, which are on the different license, which is the 3-clause BSD license, which is even less restrictive than Apache v2. So it allows also contributions of patented code, but it's much more permissive than that. And the reason why these two sub-projects are on the 3-clause BSD, because these have been integrated in other projects, most notably the Facebook Magma project. And the OAI public license was not an option for them. So we changed the licensing. All right. Now, as I said, OpenAirInterface is open source, and the code is available without any restrictions for anyone under these links. So we have they're spread over different repositories. For example, the radio access network you can all find at EURECOM's GitLab server under the project OpenAirInterface 5G. The core network is again split into several sub-projects, but there is a top-level project which is called the Federation. So the OpenAir EPC Fed project, where you can find all the information, which is hosted on GitHub. The 5G core again is hosted on EURECOM's GitLab server, as well as the Mosaic 5G project. There are mailing lists in place for users and developers where you can get help. We have regular meetings that are open to anyone who wants to contribute to OpenAirInterface. And there are other tools too. So yeah, I forgot to mention the OpenAirInterface is also unique in the sense that it's a collaborative open source project. So we accept contributions from anyone who signs the contributor license agreement. And the contributor license agreement basically just states that you respect the terms of the open source licensing model. Okay, so anyone is welcome to contribute, and if you do want to contribute, please do get in touch with us. Because one of the mandates of the Alliance is also to coordinate the development of different contributors to make sure that there are no gaps and there's also no duplicate work being done. All right, so next I want to talk about the 5G the first project within the Alliance, which is the 5G radio access network. So you can find more information also on our webpage. So this project group has these sponsors here: Facebook, Sequence, Xilinx, Interdigital, and Power. And as you can see here on the right, there are many contributors. There are also some, so I would like to point out here, there are also some contributors from India. So we're happy to have the Indian Institute of Science, who is a big contributor. And there's also a company called Global Edge Soft, which is in India, who has also contributed some code in the past. All right, so here you see the different development phases of our code. So on the so this I only include here the more recent 5G developments, and I'm not going to talk about the LTE anymore here. So you know, 5G is being deployed in let's say 2 stages. The first one is the so-called non-standalone mode, or also called the EURECOM dual connectivity, ENDC, which is the mode that's chosen by most operators. So in this mode, the 5G network relies on it's basically an extension to the existing 4G network. So you need, it's an add-on to the 4G network, in the sense that it works with the 4G core network, the EPC, and it also needs the UEs to be initially connected to the 4G network, to the E0B. The UEs, the LTE network provides an anchor to the system, and in fact, all the control plane messages are still exchanged over LTE, and only when a UE is in the coverage of a 5G cell, the network will activate the 5G cell, and the UE can connect to the 5G cell. So the G0B is connected here over the X2 interface to the E0B, and it will support this dual connectivity. So in OAI, we so since this was the chosen mode by most operators, we also decided to implement that one first. But even before, we implemented yet another mode, which is not really standard compliant, but which allowed us to test internally our code, which is what we call the NoS1 mode. Okay, in the NoS1 mode, basically you operate G0B and UE without any of the control plane procedures, just the user plane procedures. So all the configuration is predetermined and not exchanged over the air. But nevertheless, with this mode, you can still have a complete IP connection. You can inject and receive traffic over an IP interface. So, and obviously, since this is not standard compliant, this will only work with the OAI UE. Then in the second phase, we implemented the complete ENDC. So this now works with an off-the-shelf UE. So we've had this since about since summer, for a year now, since summer last year. Excuse me. Yeah, since basically summer last year, we have then focused our developments on the standalone access, which is the second phase of 5G NR. So in this mode, the G0B operates with a 5G core, and thus has all the control plane interfaces through the 5G core, and does not need anymore a 4G system. Okay, and we had this SA. So the initial standalone access we had earlier this year, and with the COTS UE, and right now we are working on the release of the code, and I think it's imminent. It's going to happen either this week or next week that we will actually release the code for SA. All right, just to give you some ideas on the status or the different configurations we support today. So in NSA, the configuration that is most tested and that works the best is FR1 TDD with 30 kHz subcarrier spacing, 106 resource blocks, which corresponds to a 40 MHz bandwidth, and SISO. We also don't support the split bearer. Okay, so in the ENDC architecture, you can actually have aggregation between the two links, the LTE link and the NR link. We do not support it. We switch basically the complete traffic is switched to the 5G network. Okay, and with this, you get a performance of about 80 megabits in the downlink and 7 megabits in the uplink. Okay, so that's for 5G not spectacular. We know that, but it is being improved. Okay, so for the uplink, we have a limitation with the modulation, and with the downlink, we at the full throughput for this configuration. So the next step to increase this throughput is to increase the bandwidth, add MIMO, and change the TDD configuration. So all of this development is already available in the develop branch. Yeah, so I forgot to mention in our GitLab repository we have multiple branches. The main branches is the master branch and the develop branch. The master branch is updated only very rarely. So in fact, all the 5G NR development is not available in the master branch and is available in the develop branch. However, the develop branch is continuously tested, and it is guaranteed to have stable code in the develop branch. All right, so if you want to build a system, an NSA system, so these are the supported platforms. So for the radio part, we have tested this with USRPs, both with B210 and N310. So in fact, you can the configuration I showed before, the 40 MHz configuration, you can even run with a B210 in SISO. But if for later deployments, if you want to go for more antennas and higher bandwidth, you will need an USRP N310, which supports up to 100 MHz bandwidth and up to 4 channels. We also work with more commercial equipment. For example, these Benetel RIUs. So they actually so they're available for both LT band 7 and then R band and 78. They support the all-run 7-to-2 split, and they also support MIMO, 2x2 MIMO, and a bandwidth of up to 40 MHz. And they are attractive because they include all the external RF, all the filters for these different bands, power amplifiers, low noise amplifiers, switches, which you don't find on the USRP. Yeah, so the USRPs are really only for lab deployments and lab tests. If you want to go outdoors, or if you want to, or even indoors, if you want the coverage that goes beyond just your lab environment, you will need either to add an external RF to your USRP, which is possible too, or you have to get one of these more commercial items. There's another one from AW2S today, which works for LTE band 38, and our support is in development. We tested this with a bunch of the NSA with a bunch of UEs that you can see here, and also with different core networks, with the OEI APC, with the Nokia LTE box, and I believe that other people in the community have tested this with other networks too. Now, about the standalone development. So as I said, we had the first complete attach in May this year, 4th of May, with some initial uplink and downlink user plane traffic. Again, validated with the B210 and N310. For the UEs, it's a bit more difficult at this point in time to find UEs that support standalone mode. As I told you, the operators are focusing their deployments on NSA. So the smartphones that you find today in the market typically do not support SA because it needs to be activated by the firmware of the phone. So we use, for our validation, we use mainly these modules. So these are these are modules that you PCI, sorry, M2 modules that are designed to be put in other products like laptops or other boxes, and that give you more flexibility in the configuration. So with these modules, we validated the SA access. We validated this also with the OAI 5G core, with the Nokia SA box, and there's another core network which is called the FreeCN that was validated. So this development is not yet part of the develop branch. It lives in a different branch for which a merge request is ongoing, and but I think this is imminent. I think just today we had a success, and the last failing tests of the continuous integration were resolved, and so we will be able to merge this into develop now. So it has some, but it has also some limitations. So the traffic is limited at the moment. So you won't even be able to achieve the traffic that I mentioned before because we still use the so-called initial bandwidth part and don't use the full cell bandwidth for user plane traffic. Maybe in the interest of time, I'll skip this here. I mean, this is just the additions that were done. So comparing NSA and SA. So as SA now supports all control plane traffic, we need to add all these features to support it. So I won't go for the interest of time in details here. What I want to mention also is the different functional splits that we support in OAI, both 4G and 5G. So this is important for you know, when you put this in the context of Open RAN and virtualized deployments. These splits are basically the industry standard now for how to deploy these different components in a virtualized environment. So 3GPP defines the CU and DU, so the centralized unit and the distributed unit, and they define this interface F1 between those two. So this interface is supported by OAI. The F1C, so the control plane, has even been tested with a third party CU from Acceleron, and the F1U is under development, and we expect this. Well, I don't think we're going to make Q2, but it's I think July we should be having that. Between the DU and the RU or the RRH, we support the ORAN 722 interface. Well, we support the user plane of the ORAN 722 interface with the Benetel RUs. But we're also planning to support the C plane, the S plane, and maybe even the M plane of this ORAN 722 interface together, and we strive for interoperability also with other RUs. And this is on the roadmap for the second half of 2021. Within the DU, between the PHY and the MEC, there's another interface which is specified by the small cell forum, which is called the FAPI, the functional API. So we have used this successfully in 4G LTE, and from the beginning of the 5G development, we were using the 5G FAP interface. So all the L1 procedures are compliant with the small cell FAP, with the small cell forum FAP interface. And there's also a so-called network FAPI, which allows you to even separate the DU into two parts and have them split over the network. And this is currently under integration as well. So there is a merge request ongoing for this too. And I have to mention that this was developed by our Indian partner at IISc. So this is being integrated right now. All right, now for the roadmap. We have a lot of work to stabilize the code. We have to improve the throughput. We are planning to include interoperability with frequency range 2. Okay, so this is the millimeter wave part of 5G. So we already included support for basic support for FR2. Including the beamforming procedures and the initial access, but we haven't yet managed to validate this with an off-the-shelf UE. So that's ongoing. We're also working on including MIMO, downlink MIMO for a start, including all the CSI reference signals and feedback reporting procedures. We're also planning to support multiple bandwidth parts. So this is necessary if you want to support slicing in the radio access network. And again, here, the IRC is one of our main partners to develop this. Later on, so on the roadmap 2022, we also plan to support localization, which is part of release 16. And we're also planning to support massive MIMO for FR1. Okay, let me be brief on this one here. I just want to mention that for SA, no, sorry, I have another slide on this. Let me skip this one. We have an ongoing project on L1 offload. This is also to help. This is with our partner Xilinx, and will help us to improve the throughput. So this Xilinx has released this T1 accelerator card, which has an MP sock and an RF sock on it, and supports offload of channel coding and decoding, as well as O-RAN 742 fronthaul. So this is under integration as well, and we hope to be showing some results in the second half of 2021. Another big project that we have in the alliance is the non-terrestrial networks. So this is part of release 17. So there's 3GPP is now finally standardizing support for satellite communication. So this is done with our partner Fraunhofer, and we're planning to bring a full release 17 compliant support for non-terrestrial networks to OpenAirInterface in 2022. Okay, I mentioned this in the interest of time. Let me skip this. Now let me spend a few words on the core network. So this is another project within the OpenAirInterface Software Alliance, with us where we have Qualcomm, Facebook, and individual sponsors, and the main contributors are EURECOM and BUPT in China. So for the core network, so as I said, I'm not the expert here, but what I can tell you, what I want to show you in this slide is how the core network evolved from 4G to 5G. So the main driver of having a new core network in 5G is to be able to well, two things. One of them is so-called control and user plane separation, which is also called CUPS. And the second driver was to be able to deploy the core network in a cloud native way. Yeah, so and having the different components deployed as virtual network functions with a common bus interface between these different components. And so at OpenInterface, this happened in 2 steps. So we had the 4G core network, and the first intermediate step was the control and user plane separation. So which basically means that the S gateway and the P gateway were split into 2 parts, one for the control plane and one for the user plane. And then basically for the 5G development, we already built on this. So for example, in the 5G, the UPF, the user plane function, comprises the functionality that was previously done by the S gateway U and P gateway U, or the SMF, the session management function, was previously handled by the S gateway C and P gateway C. Okay, and then MME is now split also into 2 parts, which is an authentication management function and the session management function. HSS is also split into 2 parts, and so on and so forth. Right now, what we have in the 5G core network are UPF, SMF, and AMF, and also NRF. Okay, so we support all the basic procedures, connection registration, and session management. We also have NF registration, NF discovery, SMF selection, UPF selection. And we actually have 2 versions of the UPF. One is, as I said, the legacy 4G version, and another UPF is relying on the VPP travel ping with DPTK support, which is the choice when you want to have high throughput. Now the original SP gateway will not support a very high throughput. The core network has been developed with is constantly being validated with a continuous integration and continuous deployment with a professional tester, and it has also been validated with the GNode, with the OEI GNode B, OEI UE, with commercial GNode Bs, for example, Amarisoft, and also with other simulators, GNode B Sim or UE RAN Sim. The 5G core network has been developed with, as I said, with the virtual network function deployment in mind. So it works on Docker containers, can be deployed using Docker Compose, or also using Helm charts in an OpenShift cluster. As for the roadmap, my colleagues are currently working on adding the UDM, the AUSF, and the UDR, and support new functionalities like N2 handover, paging, HTTP2 and FQDN support. Later this year, going even further, including functions like AF, NSSF, and NEF. We also want to integrate with more commercial UPF equipment and support network slicing and microservice architecture. All right, I said this already. All right, I'm speeding up because I want to spend some time also talking about this, because I think this is important. How does OpenInterface fit into the Open RAN context? As a reminder, current industry interest is changing from a traditional RAN to an Open RAN. Okay, and the main driver is that traditional RAN equipment mostly is proprietary, comes out of a single vendor with not much flexibility between the different elements in the network. Whereas Open RAN splits the different elements into pieces with well-defined interfaces within the pieces that allows you to mix and match different code or products from different vendors, and it also allow you a tighter control on these components. So it follows the software-defined networking concept, yeah, it's a software-defined approach, where basically everything except for the radio unit functionality can run on general purpose or virtualized infrastructure. So how does OpenInterface fit into this Open RAN? So OpenInterface is one piece of the puzzle in this Open Run component. So as I said before, OpenInterface implements core network and CU, DU, and to some limited extent also the RU. Okay, so it can be used. You can use OpenInterface as virtual network functions within Open Run deployment, but this is not everything. If Open Run, for example, defines interfaces, the E2 interface, which allows you to connect CU and DU to a controller. So the RAN intelligent controller that allows you to control several elements of the network. Yeah. So in this sense, if you want a true O-RAN deployment, we need to have interoperability with other projects in this ecosystem. So here I just list a few of them. So you have different projects that deal with intelligent controllers, network slicing, and mobile edge computing. You have other projects that deal with orchestration and automation. And then yet again, below here, you have software project that deal with how to run these components on a virtualized infrastructure. Yeah, so for example, you have OpenStack, Kubernetes, and OpenShift. And there of course there are many more other projects that I haven't listed on here. But what I want to show you next is two aspects of this that we actively work on within the Alliance. One of them is Mosaic 5G, which comprises different elements. For example, a Flex RIC and a Flex CN, a flexible RAN controller and a flexible core controller that uses this E2 interface defined by O-RAN to communicate with the different elements. And then there's another component here, that the Telematics that deals with the orchestration and management. Skip this. So the other project that is worth mentioning here is the OpenAir K8S project, which allows you to build containers on these of these different software components. So you can basically run all the different components in a container, and there are tools in there that let you deploy these containers on an OpenShift or enterprise-grade Kubernetes environment, making use of K8 pods and Multus CNI for networking. And yeah, unfortunately, I'm running out of time, but this is also what we use in our lab environment here at EURECOM. So we have built a test site at EURECOM. So here you see the campus where we have deployed radios outdoors and indoors on different frequencies. So we have licenses to transmit on these frequencies. And yeah, these are the indoor components. And this is, for example, our outdoor component. So we have this is actually built on USRPs together with an external amplifier and a commercial antenna. So we use this for both our 4G and 5G campus network. And this is all. And yes, we also have experimental equipment for millimeter wave. But this is, as I said before, is not yet validated with commercial UEs. I mentioned this already. What I wanted to say before I conclude is that we also have in our server room, we have a virtualized infrastructure powered by Red Hat OpenShift to run all these different components of the core and the radio access network. So we have basically a little experimental Open Run deployment here at EURECOM. All right. So let me conclude. And if you have questions to some of this, I'm happy to take them after. So OpenAirInterface is growing. I mean, you can see that there's a lot of things to talk about, and I don't even have time to cover them all in 1 hour. The demand is certainly growing. So you can see from the members that have joined the OpenAirInterface Alliance, that demand is growing, and they are giving us donations to develop more features. They're requesting more features. They're also requesting, and this is very important, they're also requesting more stability and testing. So OpenAirInterface is still an experimental platform. It's not a carrier grade software that you can take today and deploy it in the field. There's still a lot of work that we have to do to make it more stable. And one key component to this is testing. So I didn't mention this, but we have a continuous integration, continuous deployment framework in place at EURECOM. But this is constantly overloaded, and we're actually looking for other sites to have continuous integration. There's one that's being built in the United States at Northeastern University that will be connected to our continuous integration platform. But we need more. We need and this is my call to you and to this community. OEI needs you. We need more developers, and we need more test sites. And we have a number of people in India that are already contributing to this. And my goal is to build a broader community, maybe build a branch of the OpenAirInterface Software Alliance in India to help academics and industry in India to build something on top of OpenAirInterface. All right, and with this, I'd like to conclude, and I'm open for questions.
Thank you, Dr. Florian. That was a good presentation covering the RAN, the core, and also the Mosaic OI. And
sorry, I had to rush over some parts.
Yes,
but you can make this presentation available afterwards. That's no problem.
Maybe we should have a full day workshop on the same or next. Okay, we can start with this, but I think this there was a plan that we just get people interested, and then maybe sometime later we bring in a full workshop. So a set of questions before I invite the audience to kindly ask questions. I can flag it here and pass it on. Before we just get started, could there's a question on licensing, but before I ask that question directly into this, could you contrast, Apache, BSD, GPL versus the OA license? What is the implication? How is OA license relate to the BSD or Apache or a GPL license?
Okay, so OpenAirInterface license is basically Apache license. So technically, there's no so in the sense that Apache, for example, is a let's say medium permissive license, open source license that allows you to mix open source code also with closed source code. Okay, so you can take parts of OpenAirInterface and even mix it with closed source. I mean, you have to take parts that were open source before, you have to keep them open source. Okay, but you can mix it with closed source. So that's the basic Apache, and that's of course also possible with OpenAir. And for example, this is not possible with a GNU GPL version 2 or version 3. Okay, you cannot mix and match this with other. If you want to build something on top of a project with a GPL v2 or v3, it has to be again GPL v2 or v3. Otherwise, so the difference to the Apache license is what I said, is the licensing terms. So we just added 2 clauses to the Apache v2 license that apply only in the case that you want to deploy this software commercially. To remind you that you're not free to use this software without paying any royalty. you have to go to 3GPP and figure it out.
Okay. So there's one question saying with OA public license, this is Mr. Gunashekar. With OA public license, it allows me to contribute patented software and get paid for it. If someone tries to commercialize, but how does keep track of this?
Okay, so that's actually out of scope of OpenInterface. If that is actually, and that's why we choose it to do it this way. That's actually handled by 3GPP. So it follows the same procedures as 3GPP. So when 3GPP keeps a patent pool. So when you have a patent that covers something that is standardized by 3GPP, you have to make 3GPP aware of that, and then they have a mechanism, a patent pool that basically vendors need to pay into when they use 3GPP technology, and that rewards then the owners of this patent. So I don't know how it works in detail, but roughly this is how it works. Basically, it's handled by 3GPP, so it's out of the scope of OpenInterface.
So if my understanding is correct, OI license is Apache license, but also allowing with Apache license plus in the sense that Apache license plus you could add patented software. But yes, how will you commercialize and so on is outside the scope of OI. That you will have to join the other SAP and so on.
Exactly. So that follows the classical business model of 3GPP.
Okay. So this trying to align 3GPP and enable 3GPP participants to use the software and develop something.
Yes.
So there's one more question. Do we have options to report issues, defects as test sites? OI community can address them and have bug-free software.
Yes.
This is from Mr. Ganesh. Yes.
Yes. Yeah. So we don't have a report or bug tracking system or per se, but we do listen to the community. So we do read the mailing lists and we do listen to them. If you have something on your mind, and we keep internal lists, we keep track of in our regular meetings. But if there's something that's close to your heart that you want fixed, I encourage everyone to join our meetings and to get involved. And it's sometimes it's not enough to just send an email to the mailing list and then hope that it gets fixed. Sometimes you need to be a bit more pushy to get things done.
Okay. So one of the reasons we are conducting this seminar and TSDSI is organizing this is to get more Indian ecosystem players to participate. So if let's say you had a choice of you had a say, where would you think the OI will be happy to get help?
Because it's a very simple reason, because there's incredible talent in India. I mean, I can see this from the few partners that we work with. There is incredible talent. We actually here in Europe, we actually have trouble finding talent to work with us on these things, and so that's one reason. So I mean, that's in our interest to tap into this talent. But I also think that OpenInterface can bring something to the community in India. I know that there's a striving telecom community at large, and there's both established players and startups. And I think especially for startup, well, even for both, I mean, OpenInterface can be one component to their success. Yeah, so there's you can build products on top of OpenInterface, and with the right business plan, I think you can manage to commercialize and monetize it.
Okay, and this one is similar, related question is, if somebody is setting up a 5G test bed or a 5G, or a 4G, 5G lab in their offices, a college or a startup or a company, how will OpenAirInterface be a good fit? I mean, maybe the answer is obvious, but I would like you to elaborate it.
Yes, well, absolutely, that's a good fit. You just have to be careful with and we see this all the time. People underestimate the radio part of this testbed. So in the sense that you also from the start you have to think about your licenses for transmitting your signals, because we see very often that people try to transmit in license bands which are actually used by others in that area, and that will cause you a lot of trouble, interference, and it can even cause you, in the worst case, it can even cause you legal trouble, but we never had that case. So you need to think about this before. You need to think about which radio equipment you use. If you use USRPs, as I said, you will be very limited to a lab environment where your items are very close. I mean, there's plenty of other pitfalls, of course, that you can go through when setting up the system. I mean, we are notoriously bad with documentation, and in fact, even there is a wiki and there is documentation available, but it's notoriously out of date. So you have to be careful and make sure you get the latest information.
So I think I would now pitch in,
yes.
Prakash and Florian.
Sure.
So grateful to you on behalf of the India EU ICT Standards Project to build this conversation. As Prakash, you pointed out, this is more like a segue into a more hands-on kind of a workshop that we plan. And just to update you, Florian, you mentioned about the spectrum. I was just reading yesterday that Government of India is trying now for a fully digitized online application. If anybody wants, frequency for doing research experiments. So probably that aspect of getting to set your test bed and those things probably are getting more streamlined, at least from the regulatory aspects. And I think we are definitely witnessing an era now where a lot of people on ground have aspirations and probably readiness to tinker and experiment. So in that sense, we as India EU ICT Standards Project are grateful to both of you, to Prakash here in India, because CDOT is definitely one of those organizations which has a lot of research horsepower and also working for the good of society, and the kind of work that you have done in EURECOM is also for the community good. So I think two of you coming together is already a good start, and I think with the wider umbrella of PSDSI anchoring this kind of community, which you already pointed out, that is a thriving community in India around telecom, is probably a very good first step. So probably we will stay in touch with you, and I don't know if you want to still move your slide and show some slide which has your contact detail, but I guess you're going
to. But that's you can find it easily on the web.
Yeah, but I guess you're also allowing us to share this slide deck.
Absolutely.
And
yes.
With that, I would like to thank again both you, Florian and Prakash, for making this possible, and we look forward for building a even better hands-on discussion later this year. So with that, thanks everyone for joining hands, and look forward to do this again. Thank you.
Thank you for giving me this opportunity. My pleasure.
Thank you, Florian. Thank you, Sachin. Thank you.
Bye-bye.
Bye.